Hello, my name's Craig Barton, and welcome to the Maths Diagnostic Question of the Week number 19, where each week I pick out a question that has been uploaded to my Diagnostic Questions website, and we look at the data on that question, so how many students have got it right, how many have got it wrong, but far more importantly than that, we also look in depth at the students' explanations to see if we can uncover the nasty misconceptions that they may have. Now this week I fancy doing one of my all-time favourite topics, which is probability. Because as we all know, those of you who've taught it, it is an absolute minefield for students' misconceptions. So let's dig ourselves out a question. So I'm going to go to data and I'm going to go to questions. And this is going to allow me to find some of the most misanswered questions in the whole wide world. I'm going to go for a bit of mathematics because that's all I really know about. And I'm going to hone in on the topic I want. So I'm going to go for data and statistics, and I'm going to go for probability. Now, before I even click on this, we can see probability only 68% success rate with probability questions. There's lots of different questions on probability, but I'm interested in these spinner ones. So I'm going to give this one a bit of a click. So if we go for this, and as usual, if at this point you fancy pausing the video and just having a look at this question, what is the probability of getting a 2 on both spinners? And firstly, what is the right answer? Because I often get these ones wrong. But secondly, what do you reckon the most common wrong answer is? And what explanations do students give for that wrong answer? So if you want to pause the video and resume whenever you're ready. Hello, welcome back. So we left on a cliffhanger here. What is the probability of getting a 2 on both spinners? Now, if my maths is right, I reckon C is the answer. But I'll tell you what, this is a particularly nasty question for a number of reasons. Firstly, it's because probability causes students no end of trouble. But secondly, probably the easiest way to approach this question is either to do a tree diagram or a sample space diagram. That way you make sure you don't miss out any of the probabilities. But it doesn't say that in the question. And these have been sneaking on GCSE papers over the last couple of years. And having read through the examiner's report, kids are getting these wrong left, right and centre. And it's very apparent that they're doing the exact same thing here. So while C's the correct answer, what percent of kids do you reckon actually got C, went for C? And what do you reckon the most popular wrong answer is? Well, let's have a look here. If I go to advanced and scroll down, and let's just go to percentages, we can see that only a third of students are going for C, and pretty much half of students are going for A, 2 over 8. So firstly, let's see how students who are getting it right are explaining it, because it's not an easy one to explain why it should be 1 over 16, but there's some beautiful explanations on the website. I really like that one. Look at that. If you think about a tree diagram, there's a 1 in 4 chance of getting a 2 on the first spinner and a 1 in 4 chance on the second spinner. If you need both to happen, you must multiply, which gives 1 out of 16. Now that's interesting. That student has really got a very methodical, logical way of thinking about it. I wonder if I asked that student why do you need to multiply, whether they'd have an answer. But at least they're setting their thinking out really clearly and probably sketching a tree diagram to do that. I also like this one as well. There are 16 different scores you could get 4 times 4. So 16 different outcomes. That's the key to getting this question. Only one of them gives you 2 lots of 2. So the answer must be 1 in 16. Beautiful explanations. Interestingly, and I've mentioned this in the blog post that accompanies this video, there's a couple of right answers but dodgy explanations. Look at that one. I think this is the answer because there is the number 1 on each spinner, and if you put the 2 ones together you get 1 out of 8. I'm not sure I really understand that. But what about this one here? I think there is only 1 chance of getting a 2 and there are 16 numbers altogether. I'd want to dig a bit deeper. What do they mean there's 16 numbers altogether there? So those 2 explanations are top 2, I think, are good ones to show to your students. And of course, when students answer this question, they'll get to see those explanations and hopefully like them and learn from them. But let's get back to the really interesting stuff. Why are students going for A? Why are almost half students going for a 2 over 8? You can probably imagine where the 2 over 8 comes from, but let's let students tell us in their own words. So let's have a little scroll down, change the explanation to A. Here we go. Look at this one. This sums it up for me. There are 4 bits on each spinner, which make the spinners up. 4 add 4 equals 8. There is 1 2 on each spinner, which adds up to 2. So therefore, we have 2 chances in 8 of getting a 2 on both spinners. The exact misconception that a lot of students fall into. Just adding the denominators together, adding the numerators together to get the answer. And again, it carries on like that. I think it's A, because this is 8 numbers altogether and only 2 numbers are 2. What about that one as well? This is dangerous. You have a 1 in 4 chance of getting a 2 on each dice, and you just double that to get 2 out of 8. How as a teacher would you show that show the students that that's not right? Would you show them that 2 out of 8 is actually the same as 1 out of 4? Would that work, or is that going to make the problem worse? I don't know. Well, let's have a talk about that in a sec when we just whiz through a few of the others. B and D, not many students are going for these. sorry, I've got a dodgy throat here. Not many students are going for B and D, but each of these reveals something important. Interestingly, B has the 16 on the bottom. So does that suggest students have figured out that there are 16 possible outcomes? Let's have a look at that one. As I say, not many are going for B, but here we go. I think the answer is because there are 2 sets of 2s and there are 16 sections. That's interesting. The student realises there are 16 different things that can happen. But do they think here that there are 2 different ways you can get 2 2s? Because you get a 2 on that one and a 2 on that one. So that's a different type of misconception, possibly a less dangerous misconception. And hopefully a sample space diagram or a tree diagram would help show the student that there's actually only one way that we can get a 2 on both spinners. Likewise, what about D? What about D? 1 out of 8. This has got the numerator wrong, the denominator wrong. So I'm thinking these students are going to have added the 2 4s together. But crucially, they've spotted that there's only one thing that they're interested in that could give the right answer. Let's have a look at that one. Let's go for D. Let's have a read what they're doing. There is 1 2 on each spinner, and you need to multiply these. 1 times 1 is 1. But there we go, there are 8 different outcomes, 1 to 4, 1 to 4, so it must be 1 over 8. Another dangerous misconception. So what are we going to do about this as teachers? What's this actually telling us? Obviously, our major issue is this 2 over 8, and we've got to get across to students that you can't simply just add the tops and add the bottoms together. Will a tree diagram solve the problem? Possibly, but my issue sometimes with tree diagrams is once students have got them set out, do they just go into automatic pilot and multiply to go across and add to go up and down the tree diagram? Do they really have that depth of understanding to know why they're doing it? I much more favour sample space diagrams. And what I like about a sample space diagram is it's going to illustrate all the different possibilities very clear to the students. And we can just count them up and circle the ones we're interested in. But there is no getting away from the fact that probability is an absolute nightmare. If that's give you a taste for a bit more, there's a few quizzes that actually contain this question, and one of which in particular I'd like you to see. So I'm just on the Question Go page here, and if I click on related quizzes, there you go. I've put together a little probability with spinners, a classic combo. Some with single spinners, some with double spinners. There's 14 questions there. That'll really test your students' understanding of what's going on there. Anyway, hope that was useful, and I'll be back with a fresh question of the week next week. Take care, and bye for now.